In this part of episode 5, I would like to talk to you about how fractions are divided. And to talk about dividing fractions, there's one little piece that I need to talk to you about first, and that's about something called a reciprocal. When someone talks to you about the reciprocal of a fraction, the reciprocal of a fraction is essentially what you get by flipping the fraction upside down. Take the numerator and the denominator and swap them. If you swap the numerator and the denominator, then the result of that swapping is what's called the reciprocal of your fraction. So for example, someone says to me, what is the reciprocal of 3 over 4? To answer that question, all I have to do is flip the fraction upside down and put 4 in the top and 3 in the bottom. If someone says to me, what's the reciprocal of 5 over 2? All I have to do is flip that fraction upside down and put 2 in the top and 5 in the bottom. If someone says to me, what is the reciprocal of 1 over 3? All I have to do is flip that fraction upside down and put the 3 in the top and the 1 in the bottom. But 3 over 1, 3 divided by 1, simplifies really nicely. If you divide 3 by 1, the result is just 3. So the reciprocal of 1/3 is 3. And someone says to me, what's the reciprocal of 4? What's the reciprocal of 4? Well, this does not look like a fraction right now, right? But remember that we can take whole numbers and we can rewrite them as fractions just by thinking about that as 4 over 1. Now, to get the reciprocal, all I have to do is flip that upside down, and I get 1 over 4. 1 over 4 is the reciprocal of 4. So now that we've talked about what a reciprocal is, I can talk to you about how we divide fractions. If I want to divide fractions, I can do that in 3 steps. Step number 1, if you're dividing one fraction by another, your goal is to take the reciprocal of the second fraction, the one you're dividing by. Once you have taken the reciprocal of that fraction, your goal is to multiply by that reciprocal. And once you have finished that process, your goal is just to simplify the result if you can. To give you a quick example of what I mean when I write these steps down, if someone says to me, what is 1/3 divided by 1/4? The first thing that I would do is I would take this second fraction, 1 over 4, and I would take its reciprocal, and I would turn it into 4 over 1. And I would multiply by that reciprocal. Instead of dividing, we multiply by the reciprocal. And once I have expressed this as a multiplication problem, I can do this exactly the same way we did in the first part of this episode. Just multiply the two numerators and multiply the two denominators, and then see if you can simplify the result, which I don't think we can in this case. Now, there is a memory aid that I learned if you're working with fractions. The memory aid that I learned was Kentucky Chicken Fried, or KCF for short. And the Kentucky Chicken Fried memory aid stands for keep, change, flip. The idea is keep the first fraction the same, change the division symbol to a multiplication, and flip the second fraction upside down. Flip it upside down to create the reciprocal. Keep, change, flip, Kentucky Chicken Fried, KCF for short. Now, to give you another example of how I would divide one fraction by another, suppose someone asked me to find 5/8 divided by 1/8. And before I go into this calculation, I just want to think logically through what this is asking me to do and what kind of answer might make sense to a division problem like this, right? Now, if I think about what kinds of physical actions division can be used to represent, I could think about this as take a pile of 5/8 and distribute that into groups, each containing one of those eighths, right? This is one way to think about division. Take a pile and divide those into baggies or divide those into portions where each portion has a set size that it's supposed to have. Now, if I do that, how many groups can I form? How many distributions can I make? Well, if I have 5/8 to begin with, cut a pizza into 8. 1, 2, 3, 4, 5. I have 5 of those 8. Then I can give one person 1/8. Another eighth goes to another person. Another eighth goes to another person. Another eighth goes to another person. And another eighth goes to another person. If each person gets 1/8, then I can create 5 groups from that. I can feed 5 people based on that portion size. I'm expecting 5 from this answer. Now let's see if we get an answer of 5 in this problem from this KCF process. Let's see if we get an answer that makes sense here. Now, if I keep the first fraction and change the operation and flip the second fraction, I get 5/8 times 8/1. And if I do 5 times 8/8 times 1, I can definitely see that the numerator and the denominator are going to contain an 8 in common, right? There will be an 8 inside of the numerator and an 8 inside of the denominator that I will want to divide out and cancel out to get rid of that 8, to make it simpler. So the 8 I divide out cancels the 8 that I had multiplied. And if I multiply by 8 and then divide by 8, that multiplied 8 and that divided 8 will also cancel each other out. So all that I'm left with is 5 and 1. 5/1. 5 divided by 1 is definitely 5. And that's what I expected based on my common sense for this problem. If I had 5/8 and everybody gets one of those eighths, then I get to feed 5 people based on that. So I would expect 5 from this kind of division problem. So let's get some practice. Someone says, what is 1/2 divided by 1/3? I'm going to keep the first fraction, I'm going to change the operation, and I'm going to flip the second fraction. And then if I multiply the two numerators and the two denominators, I get 3/2. I don't think that can be simplified anymore. Someone says, what is 3/4 divided by 1/2? 3/4, keep, change the operation, flip the second fraction upside down. Then 3 times 2 is 6. 4 times 1 is 4. And I get 6/4. And now I will check to see, can this answer be simplified anymore? Is there a number that goes into 6 and a number that goes into 4 also? And I think there is. I think 2 goes into both 2 and 4. So if I divide both the numerator and the denominator by that number, I get 3/2, which would be my fully simplified final answer there. Someone says to me, what is 5/6 divided by 1/4? 5/6 divided by 1/4. To answer that question, I'm going to keep the first fraction, change the second fraction, change the operation, and flip the second fraction upside down. Kentucky Chicken Fried, keep, change, flip. Now I can multiply the two numerators together. 5 times 4 is 20. 6 times 1 is just 6 again. And let's check our times table to see if that can be reduced at all. I think 6 and 20 only appear together in this row. They have 2 in common. And so if I divide out 2 from 20 and 6, then I get 10 in the numerator and 3 in the denominator. I get 10/3. And someone says to me, what is 2 divided by 3/4? I can think of 2 as 2/1. Change the operation, flip the second fraction. 2 times 4 is 8. 1 times 3 is 3. And I think that's it for simplifying that. And then finally here I have 5/4 divided by 2. 5/4 divided by 2. 5/4 times the reciprocal of 2, which is 1/2. This will become 5/8, and I don't think that can be simplified any further.